And without much further ado, I will pull our first speaker on stage. Florian, I'm super excited to have you here today. We met it's already been 2 months almost at Oxidize, and I was super excited to see Bevy in a very non-game development space. And you're gonna tell us more about that today, right? I'm gonna pull up your slides. So take it away, Florian.
Thank you very much, Stefan. I actually thought that it was 1 month ago, but time flies by very quickly, obviously. So hi, my name is Florian. I'm with Electrobit now for almost 20 years. It's basically most of my working life. In very different positions, but always very development related. And today I would like to show you something which we created last year, which was kind of an experiment at first. And then it turned out to be a quite nice thing to show at exhibitions and like at the Oxidize conference. Okay, maybe to give you some idea what Electrobit is, because I think it's not the most known company in the world. We are a company which creates software for cars. We are working together with a lot of different car manufacturers. Not completely limited to automotive, but mostly we are doing automotive and mostly we are doing software. We have offices in a lot of countries in the world, 4,000 employees. What I find very interesting is that we have software running in 600 million cars worldwide and 5 billion embedded devices. And maybe you're asking yourself, how does this fit together? We are in automotive and we have so many more embedded devices compared to cars. The reason is quite simple. Each car has a lot of control units like airbag controller, engine control, braking, and so on. And if you count all of them together, you get a quite huge number. We have a lot of different products. I'm not going through all of them right now. Maybe just to highlight two of them. One is EV Corbos, which is our own Linux distribution. I hope that one day I will be able to show some Bevy application on this Linux version, which is based on Ubuntu, by the way. And we also have EV Trezors, which is an operating system for very, very small control units. Like if you have just a few kilobytes of RAM for airbag control, for example, where you have very strict function safety requirements and also timing requirements, then this is a nice product. And we are also creating so-called cockpit solutions. And this is something where we are also very proud of. This is the cockpit from the Sony Honda mobility car. The car is called Afila. And basically the whole display that you're seeing there is coming from Electrobit. Also, the kind of computer which generates all the image data is coming from Electrobit. We are using a Qualcomm processor for that, which has 8 CPUs and 12 gigabytes of RAM. And on this device, we have 2 operating systems running at the same time using a hypervisor. One of them is Android for the right-hand part. Infotainment is often done today using Android. And on the left-hand side, behind the steering wheel, you have the instrument cluster, a modern instrument cluster just consisting out of one display. One thing I would like to note there is that the image of the car in the cluster instrument, that's not just an image. It's actually rendered in 3D, and it can rotate depending on the situation. For example, if you open a door, the real door of the real car, then this is reflected in this 3D image. So you can see how the model opens the door, and then it rotates into a situation where you can clearly see what is going on, which door is open. I think also some lights like indicator are synchronized between the real car and the 3D car, which is rendered there. And this is something which was very impressive for me. It was done using a commercial gaming engine, which maybe starts to explain why we are using or experimenting with Bevy, which is of course written in C++. And I was very interested about Rust. I started becoming interested about Rust something like 3 or 4 years ago. And whenever I wanted to talk projects into using Rust, then one of the questions which came up early were always, does Rust support QNX? And back then we did not have, or Rust did not have QNX support. So this is something I have added last year together with BlackBerry. BlackBerry is the owner of the QNX operating system. QNX is, by the way, an operating system which is also a real-time operating system, which is used very often in the automotive industry. As soon as you're having bigger systems like infotainment systems, then QNX is used quite often. So I added that. But still, it was not so simple to convince our risk-fearing people. Customers were afraid to test or to use this because we only had very small test application. I mean, we had something like 20,000 test applications from the Rust standard library, but nothing bigger, something which is more impressive, where everyone understands, okay, this is something serious, we can really use this in a product. And yeah, so last year we talked about that, and then I had the lucky situation that one colleague of mine who implemented a lot of instrument clusters in the past had a few weeks of free time between 2 projects, and he wanted to learn something new. And he already had something like 2 weeks of Rust experience. Experience meaning he read the book, and he did some Rustlings exercises for a few days. And I was able to convince him to give this a try. And I read about Bevy, which is quite, as you know, very popular in the Rust community. Yeah, and then he started watching YouTube videos, how to use Bevy, what is an ECS. And within a very short time, which was, I think, 5 weeks, he was able to implement a not completely full-featured, but a very nice instrument cluster software, which has typical items that you can see there, which is interactive, which I was then showing at the Oxidize Conf, also other exhibitions, what you can see here. So the basic layout of this demonstrator is basically the same as you can see in the Afila car. We have Android on the right-hand side. We have QNX with a cluster instrument on the left-hand side, which is usually behind the steering wheel. Yeah, and it has almost the same hardware. Also, a lot of the software stack is the same, with the main difference that the cluster instrument is written Rust using Bevy. And yeah, it's not so easy to, or not so nice to see it on this photo. So I'm now going to show you this live. So let's stop the presentation and pray to the demo gods that everything works fine. Okay. I hope that you can see this window now, but it looks good. So this is the cluster instrument, which is a little bit advanced to what we have done last summer, and I can control it a little bit with my keyboard. So if you hear me clicking, then this is when I remote control it. We have some startup animation with logos and this build-up animation of the tube in the middle. I can pause it to show some aspects, like we have this trip info tile on the left and some infomercial slides on the right, which was nice for demonstration purposes when someone is just walking by at an exhibition, so that they get some additional information. But basically, we can do a lot of things here. We can enable telltales, for example. I can change the speed. The blue gradient, by the way, is created by a special shader that we have written, which was really fun to use because of the file watching feature in Bevy. We found out that it is extremely nice that you can change some shader code, press Ctrl S to save it in any editor, and immediately, without having to restart the application, to immediately see the effect. That was really, really great and fun to use. Okay, so this is something we have shown at the Embedded World in Germany, for example, in April. But still, there was kind of the impression that this is just some video which is playing in a loop over and over, and after some time it simulates a shutdown and it starts again. But the overall impression was that this is like a video. And we wanted to change that. So what we created then for the Oxidize Conf is another application, again created in Bevy, which is running on Android. And we can then use this to remote control our application. Yeah, and it's working. So for example, I can pause the video and switch on some telltales and add a media status, which you can see there. It's now just dummy data because usually this data comes from the Android system. And if you play back something there, then we get the actual title, subtitle, and also a small picture cover image from the video or from the song that is being played back. Okay, so these are the two applications that we created, which are very truck specific. This is one HMI concept that was once created at Electrobit to do some experiments. Yeah, so one thing which I was asked often, and which was also not clear to me at the very beginning, was how to bring car data into the application. I think you all know how to model such applications, like the instrument cluster, but how do I get actual car data into it? And for this, we had a very simple module created, which just reads strings from standard in line by line. Then we are using 30 to pass the string into an enum value that we are sending via a crossbeam channel. And then on Bevy side, we have a very simple system which polls the crossbeam channel for some events, maps it into more specific Bevy events, and then just sends them there. So for example, if I get an event to pause the simulation, then I would send something to our or send a state event. And a media event, for example, is then sent to a different event, so that our correct module can process it. Okay, so let's go back to my presentation, which is almost done. Yeah, so this is what I was showing there, which was great. There is one thing that is a bit unfortunate, which is we did not get 3D running at all on the device. I experimented a lot with different conditional compilation switches that I found in the source code. And with those switches, I was able to bring the shader compiler into a state that it would accept my code at the beginning, that it does not complain about missing shader features. But it always failed compiling them. So if there is someone in the round who would like to do some live coding one day to bring at least a very simple scene running or starting. At the moment, it's just sufficient to have a 3D camera spawned, nothing else, and it would just panic at startup. That would be great. If you want, then please let me know, and then maybe we can improve that. Yeah, and then I would go for the conclusion. It was very fun to do that. We learned that using Bevy is very simple, even if you do not have a very deep Rust knowledge. And I think part of that comes from the ECS, which kind of fixes or works around borrow checking issues. We almost had none of them, if at all. That was really great. One thing where I was really impressed is that the person who did the first implementation in those 5 weeks, he has a lot of experience with very different tools, like different HTML5 frameworks, Qt, Kanzi, which is a no-code solution often used in automotive. Also, he has a lot of experience with some in-house tooling that we had at Electrobit. And he told me that using any of those other tools, even though he has much more experience with those, would not be much quicker or easier or more productive compared to Rust and Bevy, even though he basically had no Rust experience and no Bevy experience. And still he would be as productive, or roundabout as productive. This was very impressive for me. So to us, it was a very successful experiment. I'm not sure whether I would use the framework today for a productive use. But if you want to have something nice running in a very short time, then I would definitely at least take it into consideration. Okay, that was all. from my side. I have some frequently asked questions prepared, but I would like to hear from you first, if you do have questions.
Thank you, Florian. Amazing presentation. I think everyone was excited to see Bevy in such a unusual environment. Yeah, we got some questions. I'm curious to see if those overlap with the frequently asked ones that you are used to. But yeah, let me read out the top voted one so far. Is the control UI running on Android with Bevy too? I think you mentioned that it does, right? And so
Yes,
the follow-up is, how difficult was it to make a Bevy program run on Android? And thanks for the great demo.
You're welcome. Android was actually quite simple. Why can't I change to the right slide? One second. That one. Okay. So we have Android on the right-hand side, and yes, this is also an Android application. And there is a package called Cargo APK. And with this, as far as I remember, we didn't have much issues. It was quite straightforward.
Yeah.
And we can easily sideload there because it's a system. The whole Android stack is coming from Electrobit. So it was pretty simple to get something running there.
Nice. Okay. Yeah, you mentioned that in this screenshot, in the very beginning of the presentation, the car was rendered in the usual game engine that you just mentioned. And the question is, which one is that? Like, which is usually used in cars for that sort of purpose?
I don't know if it is usually used, but I do know that Unreal is used in some cars. Or at least there are experiments with it. I'm not sure if it is in a series car, but I have seen it in demonstrators.
Okay, interesting. Next one. Does that mean you run Rust on these billions of embedded systems? I think we heard that Bevy is not in production, but how about Rust in general?
Rust in general.
Like, is there any car that runs
the
with Rust
Afila
code?
car? This one definitely will have parts of the cluster instrument rendered in Rust, not using Bevy, but rendered in Rust. The reason for this is quite simple. Well, there are two reasons. One is if you are standing next to the car, open it, sit down, then you want to start driving. And this takes something like 1 or 2 seconds. And we can start up QNX in this time and also start up a small Rust application in this time frame. But you cannot boot Android, for example, which is why it needs to be running on QNX. And this is one of the first cars where we are deploying Rust code, at least on QNX side. In our EB Corbus Linux, we also have 1 or 2 applications which are written in Rust, which are also open sourced. But I don't know whether they are in serious cars or not. Okay. We are having different projects and products where we are starting using Rust.
Yeah. The next one is personally interesting to me as well, as I'm a victim of the Bevy UI myself. So the question is it Bevy, vanilla Bevy UI that you're using there? If not, yes. What else? Or is it just a dummy?
Well, I can show you all the code if you want. But it's just vanilla Bevy. On QNX side, we have 0.2 12, I think. We started with 0.9 and then upgraded from time to time. And I even did these 3D experiments with 0.13. But there it was still not running, so we stayed at 0.12. But it's vanilla Bevy. Well, the Bevy code itself is vanilla, but we have some QNX-specific adaptations, I think, in WGPU and WInit that we need for QNX to control, for example, on which display our image shall be shown. So this is the only change that we have done.
But the question was specifically about Bevy UI. So these elements, like the coming in of the media player and stuff, this is not fake. This is actual UI elements. Bevy UI elements.
Can I move that there? So everything that you see here is done with just Bevy UI.
Nice.
Well, the thing in the middle, the tube in the middle, is just standard Bevy stuff, like normal entities and then images. And the tiles on the right-hand side and the tile on the left-hand side, they are actually UI elements where we are using CSS, for example, to render the table and lay out the table. And the table is also live rendered. It's not just a picture.
Wow. Okay. Yeah, I mean that would be a whole different conversation to look at the code of that. That must be a giant. But yeah, that's pretty impressive.
Not that much. If we have time left, I can show you this for a minute.
No, I think we have still a bunch of questions, and I know that you are also tight on time today. So I would like to go through the last, probably just one more question, and then we will also answer. So how do these two systems communicate with each other? I'm not sure if you mentioned that, like the Android and the QNX side.
I did not. But I'm happy to show you that. So we have this one thing which is reading from standard in, and we have a very special automotive protocol which is used to communicate with Android. And there was some existing code there that I've used to get media information, but media information only. And we had this existing C++ code base, and I just stripped away everything, changing it so that it creates some simple strings, some simple JSON strings, which look basically like this. This is a script that I'm using to have some randomized activity there as well. We also have a web server there that we are not using to communicate with Android. And so that is for media. And for our control application, which is somehow behind the other thing, that's strange.
That's funny.
So this one communicates via UDP. And UDP is that simple in Rust. As you know, we open a socket, read some data, convert it into a string, and after that, everything is the same as with a standard input. We split it into lines, parse it into an event, and send it. So that's basically very, very simple. And for the web server, this was kind of another experiment. I just wanted to see how hard it is to get a web server running on QNX. Probably I'm the first person in the world who tried to do this in Rust. And it was like 1 hour using a tiny HTTP. That was very simple and straightforward. It just worked.
Nice. Okay.
Yeah.
Look, Florian, that was super impressive, and I can't wait for you to eventually tell me which car to buy to really run on Rust and drive on Rust.
Yeah.
So yeah, thank you so much for your presentation, and I'm excited to see what else is coming there in the future.